Hey guys, welcome back. All right, so in this video, we're going to talk about how we architected our warning system for the race car. Now, this is something I've been wanting to do for years. So I've put a lot of thought into how I would want to do this, how I'd want it to respond. And let me show you how we're doing this. So what you're looking at here, this is a metal panel that we're going to get laser cut. It's going to get put in the car. And this light, when you're racing and you're looking straight through the windshield, right down the center, right below your field of view, if you were to nod your head down just a little bit or your eyes would line up with this circle. This is a big ass green light. Now, when you're racing, all you need to see is that green light is illuminated. As long as you see the green light, you know all your critical systems are being monitored and they're all in acceptable, normal ranges. That's awesome. You don't have to stare at gauges. You don't have to wonder, like, hey, what about this? What about that? You just know that you're good. That's amazing. Always wanted this. Now, sounds awesome, but how do you do it? Well, let's talk about that. So you got our big green light here. This is our row of warning lights. So warning lights are red. They're the next ones in your field of view. And then these are your row of caution lights. So for example, this pair here, up and down, this might be like oil pressure, fuel pressure, coolant pressure, air fuel ratio, whatever. We got a bunch of stuff. But that's how this works. Um, let's see. Okay, so one way you could do this, like in this example, we've got 8 lights here, 8 lights there, plus this light. So you're talking about 17 lamps. Now, to turn 17 lamps on, you need 17 wires and then a common for like ground or 12 volt. So you're looking at 18 wires bare minimum to run this display. Now, I can't really change that necessarily, but what I can do, so think about this. I've got to measure all these signals, right? I've got oil pressure, coolant pressure, all this stuff. So I run an MS3 Pro like plenty of people do in the Miata world. And as a lot of people know, you only get so many analog inputs. That's frustrating. I would love to have more sensors, but it's expensive to buy an upgraded one, and I already got this one. So here's what we're gonna do. Arduino. Arduinos are cheap. You can do so much with them. And I know enough about how to do some basic hardware and code that I'm going to be able to make this work. So what we're going to do in the floorboard, we're going to have our MS3 Pro. Right next to it, we're going to have an Arduino. So let me show you how we're going to implement this. Okay, so these are shields they sell. So this is a kit I bought off of Amazon. And what it is you buy an Arduino Mega, and this shield has like terminal strips that it like plug right into the board. And it comes with a case as well. Here's a good zoomed in picture. So you plug all this in, it goes in a case, and you can see like here's analog 0, analog 1, analog 2. They're just labeled. All you got to do, take a screwdriver, stick the wire in, tighten it down, done. So this makes the wiring part really easy. And then this little box could be right behind the lamps. Like you could just build a bracket and clamp that stuff to, whatever, like bolt it down and hook the wires up real easy. So that part's easy. But we've got to be able to tell the Arduino what to do. So how would we do that? So we're actually going to need 2 of these. So we need one of these in the floorboard. That's where like sensor data is going to go into that one. And then we need another one up at the dashboard in the warning panel to turn the lights on and off. And then the two have to talk to each other, right? So how do we do that? Well, another Arduino purchase. This is a CANBUS shield. So this guy, it's like 20 something dollars, plugs in. Now in my case, I'm gonna have to run some wires because I've already got a shield on there. But this gives you the ability to transmit data back and forth using CAN bus. Now, I considered doing a wireless data transmission. I still want to play around with it one day just to learn how to do it. But let's be honest, in automotive environments, CAN bus is well proven. It's only 2 wires. So the engineer in me eventually said just do what works. And CAN bus in automotive just works. Also, these things are cheap and readily available. 30, I thought it was $28, but whatever, $33. I think the price went up. Pretty sure I paid 28 for this. And then they have libraries to make these things work. Let me show you what that looks like because it's really not hard. Okay, so this is an example of some code. So, and then I modified it a bit to make this work. So I'm going to jump into the code, but let me mention this. What's so cool about this is by doing an Arduino setup like this, Like the one in the floorboard, I mean, the Arduino is like $30. The little shield was like $50. I mean, you're talking less than $100 for all the hardware, right? And I'm going to have 16 analog inputs and a ton of digital inputs. And honestly, if you ever want to expand that, it's Arduino. It's really not hard to like drop a shield on there and have more stuff. Or just put another Arduino and put it on the CAN bus, have two of them. So the ability to modify stuff, like the ability to change it without having to redo everything, is a huge pro to this. Another one. So we talked about in the dashboard that it takes 18 wires. Now what we could do is just run the wires from say the floorboard to the dash. But what about in the future if we want to like change our dash panel, like we saw that today this thing has 17 lights. But maybe in the future I want to add some stuff or change some stuff or whatever. That would require physically rewiring the car. That kind of sucks. By doing it this way, going up to the dash, all we're going to have is like battery voltage, ground, CAN bus high, CAN bus low. That's it, four wires. And even if we change this, like say down the road, we could have an LCD display, we could have different lights, we could have whatever we want. It's still the same four wires. So the hardware side of it, like I could go develop a new one of these, like a digital. I'm not going to do it probably, but like say you did an LCD, I could go develop the LCD, get it working, bench test it, develop the firmware, test it, make sure everything works. The whole time my car still has the old system working great. And then once everything's developed, you walk up to the car, you bolt it in, you plug it in, and that's it. You update firmware on your master and slave device, and that's it. You're done. It works. So that's one of the beauties is this is very easy to like upgrade in the future. That is awesome. So that's another reason we're doing CANBUS. Now I'll admit I was a little scared, but it turns out this wasn't bad. There's the modules I bought, they come with like a Arduino library specifically for this module, and they have examples that already work. So I just took their examples, loaded one, like this one's called send, the other one's called receive. Like I'll show you, you straight up, like this is actually easy. If you guys ever want to get into this, you just go to examples. You have to install the library, but it tells you exactly how to do it. You just go down here, it says CAN bus shield. And then look at all these things like receive blank and send blank. That's the two that I used. And I just modified them to do what I need. But I loaded these up and they worked. Like, they were sending data back and forth through CANVAS pretty easy. So I was like, hey, that's nice. All right, so let's get to the code. So here, the original one, this grayed out piece, they just sent this thing here called STMP. So I renamed it to be message one and message two. Now, what I needed to send 16 things instead of 8, so I just changed this to 16, but turns out that doesn't work. Something about CAN bus, you can make this like 1, 2, 3, 4, 5, 6, 7, 8, but you can't go higher. So didn't realize that at first, but turns out that was a problem, so no big deal. Just made two messages. And then down here, again, you can see I grayed out. This is like their old stuff. Looks like I grayed this out. Not sure. Maybe I shouldn't have done that. I don't really know. Maybe that's a comment. I don't know what that is. But anyway, here's I grayed this out and made my own. So it's like, oh, send message buff. And then they use the address 0 hex 70. And then I just copied it. And then the next one, I just bumped it up to 71. These two numbers, all that stayed the same. I wonder if that 8. Maybe that's the number. I don't know. Might be showing my ignorance. I don't know what this stuff means. But then this part, I just changed it to be my message. So I made it message one and message two, send those here. That's it. That's CAN bus sending data. Pretty straightforward. Now let's check the other side. The receive side, kind of the same deal. The setup stuff I didn't change. This loop. They had this thing where it says check that it receives something. And then it says, hey, this part I added. I was like, hey, if the CAN ID is exactly equal to, I think they had something in here, but I modified it. So I've got two different if statements. One of them checks for one message, one of them checks for the other message. Now this isn't totally finished yet, but what you can see is this will print out whatever's in the CAN bus, right? And I tested this, it works. I don't have it like running right now, sorry about that, but it does work. These messages over here, here's the variables that I initialized. This is variable 1 caution, variable 1 warning, and this goes all the way to variable 8 caution and variable 8 warning. And that shows up in the messages over here, so like it did work. It's still got to get modified, but what this did was this proved I could make CAN bus work, and this took like maybe 2 or 3 hours and it was up and running. So another few hours to get all my variables defined and get them over here, and and we'll be golden. So I was like, okay, that's not bad. Pretty good stuff. So yeah, so that's basically how we're going to architect this. Like I said, this gives us the expandability. We can change stuff, which is really cool. And it's CAN bus. I've always wanted to get into that. Maybe in the future we might throw some other CAN bus stuff on the car. Uh, One thing I think I forgot to touch on, but let me show you real quick. Okay, I think I forgot to mention this. But if you notice right here on the CAN shield, it has a little slot for a micro SD card. So you can actually use this as like a data logger and store stuff on an SD card. That's kind of cool. We're not going to worry about that right now, but like, yeah, in the future, we could turn this into another data logging system and potentially a nice one. So that's a nice little bit of functionality. And then of course, just basing this on Arduinos, like we'll be able to upgrade stuff, change stuff. Doesn't cost $1,500, $1,800. Like this is stuff that like normal people, or at least me, I can afford this. Like I can go buy a $33 shield, like that's not going to break my bank account. So that's cool. I love being able to do stuff like this, on a budget and get the performance and the functionality. So that's cool. Now, you guys stick around. I will have videos actually building this to a decent automotive standard. I'm not saying it's going to be perfect, but I know the core stuff I got to do to get right. I think I do the core stuff to get right so that this will actually work in your car and not be buggy. Just to throw a couple of them out there for y'all. If we go back to, this isn't even an Arduino, but here's one. So if we go here, these guys, one of these pins actually says 12 volt somewhere on here. I don't see it. Yeah, VN. That pin will run on 12 volts. But guess what? In a car, cars are not 12 volt, especially mine. Cars usually run like 14 volts, sometimes up to 15 volts, and they can have spikes higher than that. My car is going to run on 16 volts, so it's actually going to go up to 17, maybe a little higher. Anyway, I just know from experience that you can run these at 12. You don't want to go a whole lot higher than that. So we will put some cheap little whatever regulator that'll take battery voltage and bring it down to actually 12 volts before we feed it into the Arduino. And it's good practice to run these on VN anyway, because if you try to like feed them 5 volts or something, they sometimes you don't get enough like amps. Like if you run it through USB or something, and you're trying to like switch a lot of pins and do stuff, sometimes they run out of power. So feeding them directly 12 volts is good for power anyway. But that's one catch. Another one is when you run this, you have to run termination resistors on the both ends of the bus. Luckily, we're only running 2 shields, so that's actually pretty easy. And then on top of that, if this shows up in the picture, it's going to be hard to see on camera. But right here, this little thing called P1, it's hard to see, but there's these 2 pads. I got to solder those together. For now, I won't tell you what I did. But anyway, you connect these two together, and it actually connects the resistor, which is used for termination. Really important to do that on a CAN bus, or bad things and noise, and it may not even work. Another one just worth mentioning, where's a picture of it? So this little orange block, this is where you hook the wires up. We may take that block off and run the wires directly to it. I don't know. That's a little chintzy, but it's probably fine. Maybe we'll leave it. But one thing you want to do on CAN bus is you want to like take the wires and twist them together. And I'll show you guys. Super easy to do. You can like take the 2 wires and literally like stick them in a drill and pull the trigger and it'll wind them up and twist them. So it's real easy to do. But that gives you oh, what's that called? It's like uh, damn it. Somebody in the comments probably remembers what that's called, but it basically does like noise cancel, common mode rejection, something like that. Anyway, you don't have to know the science, but it does work. It gets rid of that noise and anyway, stuff like that. So we're going to get this set up and we are going to have CAN bus and we're going to have all the sensors coming into our Arduino. And it's going to be pretty sweet. I guess the last thing I'll mention, because I started building all these wiring diagrams, which I'm sure nobody cares about that. That's why I'm not filming it. But I did realize a grounding problem if I tried to share sensors between between the MS3 Pro and this. So that's one of the reasons that we're going to be sending all of our important sensors are not actually going to the MS3 Pro. They're going to go to this. And then once this, we'll be able to take that data inside the Arduino where it's being measured. It'll take that data and through CAN bus, we'll be able to actually CAN bus it over to the MS3 Pro. I think we can do that. So it's kind of like a cheat code of like, how do I get 20 or whatever, however many analog inputs you want? How could I put that on an old MS3 Pro? Well, They have CANBUS. You can actually do it that way. I'm pretty damn sure you can do it. I've saw the settings. I haven't done it myself yet, not that part, but we will. But I do expect that eventually all of this data will actually be over on the MS3 Pro via CANBUS. So that's a nice little upgrade for any guy, especially if like in the future you guys want to add some sensors to your car, or try to build a system like this. I'll show you how to do it, make your lives a little bit easier. Anyway, guys, hope you enjoyed this video, and I hope it recorded correctly because this is the second time I filmed this, and the microphone uh, didn't agree with me on the last one. So hopefully this one worked out. Let me know what y'all think. If you got any questions, let me know. And till next time, y'all take it easy.